my name is Jeff Fecto. My title is a Senior Regulatory Engineer with UL. As David said, Jeff Simpson and I worked together years ago as inspectors. I was a senior inspector and he was one of my electrical inspectors. And then when I left, he took over as the senior inspector, and now we work together again at UL, and Jeff covers your guys' area. And I do the same thing that Jeff does, but I do it for the southern states, basically from Texas to Florida along the Gulf, up to Virginia on the east, and then Kentucky, Tennessee, and Oklahoma. So I got a pretty good area, but as David said, we're going to talk about fire stops tonight. And a lot of times these type of items out of other codes, people don't realize how to apply them in the NEC. And the NEC is pretty silent other than really in chapter 3 and 300.21 that gives a blanket requirement that just says, hey, if you violate a fire membrane, you have to maintain that integrity. And we'll talk about a couple of other places in the NEC that address it, but still very vaguely. And there's a lot involved with maintaining the fire integrity of a building, and the majority of that comes out of the building code. But we'll touch on the plumbing and the mechanical and the fuel gas code as well, the International Existing Buildings Code, the Property Maintenance Code. So this is an example of all the parts of a building that fire stopping in one way, shape, or form will affect. And I'll make this handout available to David and Robert, and they can disseminate it accordingly. But today, mostly, we're going to talk about membrane penetrations and how you maintain the integrity of a fire-rated assembly when you have to make a hole in one side. So when you have fire stopping, the intent is to prevent the fire from going in other parts of the building. You're trying to compartmentalize it so that it can't spread. And when you don't have fire stopping or inadequate fire stopping or fire stopping that has been breached and not replaced, well, that's when fire gets to spread. And the picture we see here on the right, that was one that I took back in late 90s, early 2000, when I was investigating a fire that was blamed to be electrical. And we all know that if they can't find the cause, it becomes electrical. Even when there's no electricity to the building. I've investigated some so-called electrical fires that the utility was cut at the overhead pole at the transformers on the pole that never even made it to the building, but yet they called it an electrical fire. But in this case here, you can see how much the charcoaling happened to the plywood, but just to the right of the plywood, it's pretty much as good as the day it went in. And you look at the face of the stud where we pulled the drywall off, and you see a little bit of smoke and a little bit of heat damage there, but the actual charcoaling happened above the fire. The fire was below that 2x4, but because they didn't properly fire stop that opening, that acted as a chimney and almost like a vacuum and sucked the fire through that 1/2-inch hole where the MC cable went through, because there was no fire stopping. Had it been properly fire stopped, it probably would have suffocated that fire in the cavity below, because you need 3 things for fire, right? You need air or oxygen, you need fuel, and you need an ignition. If you take any one of those 3 away, the fire can't sustain. Even if it's already started, it can't sustain. If it runs out of oxygen, it'll burn itself out. And if you have any doubts about that, next time you're burning a candle in a jar or in a container, just either put the lid back on it or put not a combustible plate, but say a stoneware type plate over the top of it and watch it. Within a few seconds, it'll just put itself out because it burns up all the air that's in that jar. So when you don't have containment, this is what happens, unfortunately. And if you've ever seen an apartment fire or a large building fire, even a residence, but residences have minimal fire stopping, and we'll talk more about that. But if you've ever seen an apartment fire where within a matter of a couple hours, it spread to multiple apartments and then burned to the ground, one thing I can assure you, it was not proper fire stopping. Because when we talk about fire ratings, they have to have hourly ratings. And if it's a 1 hour rating and it's done properly, it'll contain that fire in that compartmentalized area for 1 hour, all the way up to a 4 hour rating. Well, even volunteer fire departments don't take an hour usually to get to a place that's on fire. So they should be able to get it under control and keep it from spreading into other units. In this case here, this became a 4-alarm fire, and 20 units and then another 25 units sustained severe smoke and water damage. So in just a small amount of time, and I'm talking about an hour and a half, went from the picture that we just showed you to the bottom center picture where that entire building was destroyed and pretty much taken to the ground. And now, had proper fire stopping been in place, now depending on if this was a townhouse or if this was a multifamily, you get different fire ratings. But had the proper fire stopping been in place, there's really no reason why this shouldn't have been able to be contained to at least 1 unit, possibly 2. So when you have proper fire stopping, again, we compartmentalize it and we don't let it get outside the area that we're trying to keep it in. So when you get into commercial buildings, office buildings, you're going to have areas of refuge and stuff that are called safe havens. You're going to have shaft enclosures and stuff that are designed to keep fire in or keep fire out, depending on the intended design. But in this case here, you got what looks like a storage room down below. If that were to catch on fire with a 1 hour floor ceiling assembly, that person above it should be safe in that office for up to an hour. Now, of course, you don't want to stay in the building that long, but because of the fire ratings and it had been done properly, that definitely gives that person up to an hour to get out of the building. And we're all guilty of it. And here's where I like in-person classes, because I can ask questions and I can see facial expressions and I can see hands raised. But think about this. How many of us have been in a building when the fire alarm went off? How many of us got up right away and walked out versus how many of us sat there and wondered if it was a false alarm and kept doing what we were doing until somebody physically came in and said, hey, there's a fire alarm, get out of the building.
Yep.
So that's why we need to maintain these fire integrity issues, because even as safety orientated as all of us are on this call, I'd be surprised if any one of us could honestly say that every time they've heard a fire alarm, they immediately vacated the building and didn't just kind of hang around and see what was going on and see if there really was a fire or it was just a false alarm.
Jeff,
So,
can I ask you, why do you say up to an hour rather than at least an hour?
well, yeah, it should be at least an hour. It's my terminology, but yes, if it's a 1 hour rating, it should not be breached anywhere within that first 60 minutes. So in this case here, we have an apartment that was fully engulfed. It took the fire department 15 minutes to arrive and get it under control. The fire started on the first floor, but the fire was contained to apartment A because there was proper fire stopping between A and B. You can see there's a little bit of smoke damage that, got around a little bit. You can see the fire came out of the upper story window, got to the fascia, damaged a little bit. But when we look inside, the fire actually started back in the kitchen. And this fire got so hot that we had flashover. Now in today's construction, that was an older building, but in today's construction, it's not uncommon to hit flashover in less than 15 minutes, because with the glued lam products that we use, with all the micro lam engineered products that we use, with all the synthetics that our furniture is made out of, with all the glue lam wood that our furniture is made out of, not made out of old, solid wood like we used to have 30 plus years ago. That stuff burns a lot hotter and it puts off a lot higher toxic vapors. And because of that, you get much higher temperatures. And at that point, the room just spontaneously combusts. And everything in that room catches on fire simultaneously. Now, back in 30 years ago, that would take probably 40 minutes to get to that temperature, but not in today's world with the construction that we have and the furniture that we have. So what is fire stopping? I'm not going to read this verbatim, but it's a process of maintaining the integrity of the fire rated wall. If we put a hole in it, we need to maintain that and fill that hole with something that's going to give us an equal rating. And we'll talk more in detail about how we're going to accomplish that. The IBC, the International Building Code. So this is where we get most of our requirements out of Chapter 7 of the International Building Code, and specifically Section 714, that gives us the mandated requirements for keeping the fire stopping and not breaching the integrity of an assembly. So by the IBC, fire stopping relates to the protection of penetrations. By industry, fire stopping relates to the protection of penetrations, joints, curtain walls, where floors, ceilings all intersect with each other. So you have a membrane penetration. That's mostly what we're going to talk about today. You have through penetrations, and that's when you breach both sides of a membrane, whether it be a vertical like a wall or a horizontal like a floor ceiling or a floor truss application for maybe an attic situation. But we have to make sure that we have the right product. So when we do membrane penetrations, there's going to be different types. And I'm going to tell you right now, fire caulk is not the fix-all. Fire caulk is not going to work in every scenario, because if it did, guess what we would only have? Fire caulk. So it's limited in its application. It's limited in the amount of area that it can fill. It's limited in the type of products that it can be used with. So in this case here, we got like a fire collar. And when you start getting up above 2 inches in your non-metallic conduit systems or your plumbing systems, the fire caulk can't expand enough to fill that void and seal the opening. So that's when you start getting into these fire collars that have enough material that can squeeze that non-metallic material, fill the void, and reseal that opening as the non-metallic melts away. But it tells us that the material or the construction installed to resist the prescribed time period for flame heat through any openings that are required to be protected, to accommodate cables, conduit, cable trays, tubing, pipes, and similar. So when you start running cable trays and things that are even more difficult to seal, there's going to be specialty products that get us where we need to be. So here's another version of a through penetration. So when you're running a lot of data cables, and I hope I don't offend anybody on this call, but the people that run the data cables and the low voltage stuff are usually the most notorious ones for breaching fire ratings. They'll take a sledgehammer and bust a 8-10 inch hole in the wall for a single 25 pair. They don't take care, and maybe hopefully they just don't know, but they don't realize breaking a hole in that wall is just giving the fire a place to pass through to the next side. So again, going into definitions, it tells us here that, again, this membrane fire stop is an assemblage of specific materials. Now, what it really should say is it's a recipe, because these are systems and you have to follow them verbatim. So I like to equate it to a recipe. And you can't just take material that looks like the same and use it. For example, when you bake a cake and it calls for a cup of sugar and you substitute a cup of salt, are you going to come out with the same product? Or when you're baking something and you need baking powder and you substitute it with baking soda, Is that going to get you the same result? And the same is true here when we deal with fire stopping. It's a system and it has a recipe. And if we don't follow that recipe, we don't get the end product, meaning we don't have a proper fire stopping system. And in this case, you're going to have F ratings and T ratings, and that's flame and time, but we'll talk more in detail about that. And then it tells us that these systems shall be installed in accordance with the ASTM E814 or UL 1479. And they're synonymous with each other. So when you have a through penetration, and here's a curtain wall, and when you have a through penetration, that's going through both sides of whatever the fire rated assembly is. And these curtain walls are pretty much taboo from running anything through them. And if you remember back, oh God, it must be 30 plus years now, but if you remember back in Las Vegas when they had the MGM Grand fire that happened on the first floor in the casino, they killed hundreds of people 20 and 30 stories above the casino, and the fire never left the casino. What killed the people was they didn't have proper fire and smoke stop. And all those chips that were burning, all that carpet that was burning, all the casino machines that were burning, they put off arsenic in the smoke. And it made it all the way up through the floors. And most of the people that died from arsenic poisoning and smoke inhalation because of improper smoke and fire stopping. Now, again, the fire never got out of the casino, but the smoke did. And it carried all those toxicities through the entire building. So 3 elements of fire stopping. You got floor or wall assemblies, you get the penetrating item, and then you get the fire stopping product. And all of these are crucial in the proper fire stopping system. Not every system will work with every conduit. Not every system will work with every cable. Not every system will work with plumbing pipe or gas pipe or whatever the case may be. So we have to make sure we got the right product, and we'll discuss that in more detail. So again, the right product for the right application. If one product did everything, how many products do you think would be manufactured? Just one. So they make all these different products because they're needed to achieve the end goal of maintaining that fire integrity. So you have different types of steel collars, you have intumescent wrap strips, you have all kinds of different products. And then how you attach the products is important as well. And we'll talk more about that, but hopefully you can see my pointer on the screen. And we got a collar with a large piece of PVC going through the wall. But how we attach that collar is just as important as using the appropriate collar. If we take this picture here with a collar and we don't attach it properly and the sprinkler goes off and the drywall gets wet and soggy, what's going to hold that collar in place versus letting that collar fall out as the plastic melts and pulls away and not fill that void? So how it's installed is just as important as using the proper product for the application. So enclosures, you have valves. Here we got like a shower mixing valve. We have a light fixture with a box type enclosure around it, but you could have speakers or lighting, and you're going to have different types of enclosures. Now, in my experience, one of the common mistakes that happen all the time is they won't use the right products. And when they are told that they have a regular can that's not fire rated, that breaches a fire rated ceiling assembly, the first thing the architect or the designer wants to do is, well, let's just build a drywall box and we'll put a drywall box over it. We'll take a couple of sheets of Typex, we'll build a box, we'll use some drywall mud and we'll glue them together and we'll just drop it over whatever. That's not a tested system, and that's not what the code would allow. Now, there are going to be scenarios where there are no tested systems to work for your specific scenario. At that point in time, what the code allows is an engineering judgment. And you would get with a fire protection engineer, and based on their experience and based on tested systems, they're going to design something and they're going to put their seal on it. And they're going to say, in their best engineering judgment, that this will give you an X amount of fire rating, whichever, you know, a 1 hour all the way up to 4 hour. So annular space is important. And in this case here, sometimes we need to have annular space all the way around the product. Sometimes it can have 0 annular space or point of contact. So when you look at the information, it's going to tell you if I have to have continuous contact, if I have to have single point of contact, if it has to be completely centered and I have to have an annular space all the way around it, or can I have it offset where it's not perfectly centered? Some of that is going to depend on the type of material we use. Is it an intumescent, which means it expands with heat? And we got different fire caulks. Some fire caulks are elastomeric, where they don't expand in heat, but they allow some deflection in the application. So, for example, if you had a fire damper, when that fire damper needs to close, you don't want an intumescent material start to expand and bind it and keep it from properly closing. But when you have a hole to fill, like a plastic conduit or PVC conduit passing through, or some PEX pipe passing through, you don't want to use elastomeric, because as it melts away, it won't expand like an intumescent and fill the opening. So you have to make sure that we got the proper fire stopping, whether it be an intumescent material or an elastomeric material. Also, how you install it is super, super important. So again, this is where I'd pose a question to people in the class if we were in person. And I would ask them, how many people have used epoxy anchors? And usually I'll get a few amount of people that raise their hand, and I'd say, okay, so when I drill into the concrete, after I pull my drill bit out, the next thing I do is just go ahead and pour my epoxy and it's at the anchor, right? And of course that's not true. You have to blow the hole out and you have to clean the hole, because if you don't, you put the epoxy in, what's the epoxy going to adhere to? All that dust. And so then you have no true pull-out strength, because it hasn't adhered to anything but the dust. So the same thing here, especially when we're dealing with brick or block walls, or even drywall, we all know how much dust is involved when we drill through those or cut through those. And so we just take a bead of a bead of fire caulk, and just put a nice clean bead around it. What's it going to adhere to if we didn't clean that out properly? It's just going to adhere to all that dust. And then when the fire comes and the pressure comes, when it goes to expand, it just pushes that fire caulk right out of the way. And then we don't have any sealant material that's going to expand and seal that fire opening. So it has to be tooled. You have to have a proper depth. So as an inspector, when you do fire inspections, I like to equate it to doing a seal-off inspection. When you go to a gas station to do a seal-off, or if you're in a HAZLOC location, you got seal-offs that you have to look at. You have to look at the wire fill, you have to look at wire separation, you have to look at the damming or the packing material. You have to look at the thickness that your sealant's going to be. All that's part of an inspection. And you have to do it in 2 steps, because if you go look at it after they poured the seal, then you have no idea what the damming material was, or how far below the opening it was to how much sealant you have. And we have sealant requirements for seal-offs. Well, the same thing here. We have requirements for minimum thickness and backing material and everything else. So if you don't see the damming material or the backer material and how deep it's recessed into the wall cavity or the floor cavity, you have no idea how thick the fire caulk is that they're spreading in there, and making sure you got the right amount, if you don't look at it beforehand, you don't know if you got the proper annular space before the sealant goes in. So these almost have to be done in 2 inspections as well, before the sealant goes in, but after it's already prepped. Or if you don't do it that way, the only other way is to start doing destructive testing, destructive inspection, where you do a percentage and you say, okay, we have 100 seals, we're going to cut 10 of them. We're going to do a 10% inspection, and you're going to cut 10 of them, and we're going to verify that once we cut them, what the thickness is, what the damming material is. And if you miss any of them, now you get to cut all 100 out and start all over again. So to be more proactive, it's best to do it in a 2-step process, where if they don't have the right thickness or they don't have the right damming material, it can be fixed there before you have to start cutting out all the fire seals. And so when it's properly installed and we have the fire, the way it expands, it actually seals against the material and uses that material to cause it to force itself into the opening as it expands and close that opening. So if it's not done properly, and we'll show you some examples of some good, and we'll show you some examples of some bad, but if it's not done properly, you might as well not do it at all, because you just set up a sense of false security. And we saw what happened at that apartment complex, and we probably all know of a scenario where we've seen a building burn to the ground in less time than it should have, or spread to more areas than it should have.
Jeff, let me break in for a moment here.
Yeah, go ahead, David.
Let it run a little past, but anybody who did not sign in initially through the chat, any members, go to chat and say what chapter you're a member of. That'll tell us, hey, you're here, and if you're here by the end, you'll have been here for close to the full meeting anyway. Also, if you have any questions, use chat, because otherwise we'll be keeping people muted, except when I need to unmute to jump in to do something. And of course, Jeff. So play on.
Thanks, David. So all that was the preface of getting us into the actual code requirements. And we'll start with the building code, because that's where the majority of these requirements come from. And and I don't mean to sound degrading or demeaning or belittling, because electrical is my passion. But if you're an electrical inspector only and you don't have building experience, and there's a lot of combination inspectors out there, but again, as a combination, and I happen to be one, like Jeff Simpson, I'm a certified building official, but I'm not a master code professional. I'm 3 shy of achieving that balance, or that feather in my cap, if you want to call it that. But I do carry 23 ICC certifications for inspectors, and I am a certified building official. So when we get into the building code, or if you're an electrical inspector and you have fire penetration issues, reach out to your building inspector, because they should know this. That's where these requirements come from. And so the penetration requirements are going to come out of section 714 out of chapter 7. And it tells us in 714.4 that penetrations into or through firewalls, barriers, smoke barriers, or fire partitions shall be protected. How mandatory are those 3 words? Shall be protected. Don't know too many options when they give you such a mandatory requirement. And it tells us they have to be protected per section 714.41 through 714.43. And then when we get to 714.5, it tells us penetrations of horizontal assemblies. So walls are vertical, floors, ceilings are horizontal. Well, guess what? Assembly is not required to be protected by a shaft enclosure. So a shaft may penetrate multiple floors without sealing at each floor level, because the shaft enclosure itself is going to be a rated assembly. But anything other than protected by a shaft enclosure shall be protected. Again, three very mandatory terms. and it tells us section 714.5.1 through 5.4. And then it goes on to tell us in 4.1 that again, these penetrations shall be protected by one of the following, and it gives us three options. It's tested as part of an entire wall assembly, and we got wall assemblies out there that are fully rated. It's tested to UL 1479 or ASTM E814, which again, they're synonymous with each other. Or some exceptions, but be cautious with these exceptions because we're going to talk to you in a little bit about heat transmission. But there are some exceptions here that if it's concrete, grout, or mortar, or the annular space is protected material. So in some cases, people will think, hey, I can just grout that EMT or that rigid metal conduit right through the floor. When the floor is poured, or we're going to box it out and then we're going to come back and pour it back in later. And that concrete is going to be my fire stop. Don't count on that right now. That may not be true. And we'll talk about that in a little bit. So when we get into 714.4.1.2, it says when it's tested by the UL standard or the ASTM application, your through penetration shall have an F rating. And F is your flame or your, basically your fire resistance is what it is. And so here in smaller font, I've got what the F rating is. And it tells us that the F rating is a fire stop considered to meet the requirements of the F rating if it remains in the opening during the fire test for the rated period without permitting the passage of flame through the openings. Again, that is key to properly installing it. Because if you don't properly install it, it's not going to last that duration. And you can see in this system, and we'll talk about how to identify systems in a little bit, but you see this system has an F rating of 3 hours. So that fire stop that goes into that penetration has to be installed in such a way that 3 hours later, it's still there. So we have membrane penetrations, and this is one of the places that kicks in for electrical. And when we get into 714.4.2, it tells us these membrane penetrations. So we're just cutting a hole in one side of the fire stop. And these membrane penetrations shall be protected as follows. And we have it specified in 714.4.1 for through penetrations. But very specifically here, it says recessed fixtures. Now that's our recessed luminaires, and it tells us recessed fixtures shall be installed so as not to reduce the required fire resistance. Now we have some exceptions. If it's a steel electrical box, but we'll talk about that, that's going to be limited to a 4-square junction box for the most part. If we have listed electrical boxes of any material, when it's installed per its listing, other recessed boxes, or annular space created by fire sprinklers. Well, why would we not care about the annular space around a fire sprinkler? Well, if it gets hot enough, the fire sprinkler is going to go off and cool it down and pretty much prevent it from getting through there. But when we look at the one for steel boxes, when we read the code, and we're talking, this is right out of the building code, it tells us it shall not exceed 16 square inches. So remember what I said about a 4-square box? We can't put a 5 and 11 or a 5 square or whatever you want to call it, a 4 and 11/16. We can't put that box in because guess what? It's steel, but what is it bigger than? 16 square inches. But then not only is it just limited to 16 square inches, but then we got to look at the opening. And it says that it shall not exceed 100 square inches within 100 square feet of wall space. And that's not a 10 by 10 dimension. It's not 10 feet wide and 10 feet tall. It may be 4 feet high and, you know, whatever the equivalent is. If it was 4 by 10, it'd be 40. So 4 by 20 would be 80. So 4 by 25, give us 100 square feet of wall. We can't have more than 100 square inches of opening. Now that's not the 4-square box opening. That's going to be the mud ring opening. So we're limited to a 4-square box. If we put a 2-gang mud ring on it, then yeah, we're probably going to have 16 square inches thereabouts. If we put a single gang, we're probably going to be down around 8 square inches. But those are all things that have to be taken into consideration. And then here, as well as what we would find in 314 of the NEC, the annular space around the opening of the box can't exceed 1/8 of an inch. And we have to do that based on the NEC, regardless of whether it's a fire rated wall or not. But here in the building code, it flat out says you can't exceed more than 1/8 of an inch. So then it tells us such boxes on opposite sides of the wall. So we got them on both sides. Well, they have to have separation. And it says, first off, your separation can't be less than 24 inches horizontal separation. And then it tells us that you can't have communicating studs. Well, if you got a single stud wall, that's pretty good because one stud blocks the other stud. But what about walls that go up in 2 walls? Sometimes they're staggered studs and sometimes their studs are in parallel, but they're still 2 separate walls and we got a gap between them. Well, guess what those studs do now? They communicate with each other. We can have solid fire blocking. We can have a horizontal distance of not less than the depth of the wall cavity, as long as it's filled with one of these types of insulation. We can use putty pads that are listed for the application. And believe it or not, they come with installation instructions. And we're going to talk about that as well. And then other listed materials and methods. So here's a typical multifamily apartment wall. Staggered studs. That is going to be a 1-hour wall if it's an apartment complex. It's going to be a 2-hour wall if it's a townhome. You think we might have some fire problems with that application right there? I can guarantee you we do. First off, we don't have the proper separation. We have communicating studs. There's absolutely no way to contain or isolate that fire in this wall configuration right here. One way would be to putty pad it and to completely fill that wall cavity with insulation, but there's other ways we could do it as well. So that would be a serious code violation, not only from an electrical standpoint of our basic 300.21 that we'll talk about in a little bit, but from a building code perspective. So here's another example. Here, the studs are in parallel with each other. They threw some plastic boxes in there. Now, are those plastic boxes rated for that? I don't know. We'll talk about that in a minute, but that would be something that would have to be verified. But then they just threw some putty pads on there. Well, that's still not taking care of the communicating stud issue. So they're probably still going to have to completely insulate that wall. And in a lot of cases, they will for soundproof reasons, but they won't use the right insulation that we showed a few slides back of what it would need to be. They're going to use a spun fiberglass, craft face paper. They're not going to put a rock wool in or a mineral wool or a cellulose type, most cases. So remember we talked about putty pads have installation instructions. So read those actual instructions. And I can't speak much for the New England area. I grew up in Maine as a kid until I was 15. I was born in Portland, Maine, but I never did any of my trade experience there. So not real familiar with how things happen back there. But I can tell you in the desert Southwest where I live that when you put these putty pads on in the summertime, and here in Phoenix, it's probably almost always summer to the rest of the country and extreme summer for everybody, because we have 6 months of hot weather and we have 6 months of nice weather. But our nice weather is your summer temperatures of 70 and 80 degrees. So in this case, it tells you exactly how to put it on. It tells you how to mold it. It tells you if it's going to go up against drywall because one side of the wall is already in. You pack it tight up against it. You have to fold it over the front of the box if the drywall is not there yet. So when they put the drywall on, it seals against the drywall. So it should look something like this. And it's packed in, molded tight, tucked to the stud, whether it be a wood or steel stud. It's molded to the back side of the drywall. That's one of the right ways to do it. But in reality, and I was riding with a good friend of mine that's an inspector out of Irving, California. And I was in town early for a meeting, and I called him and said, "Hey, James, I got some hours to kill. Can I come ride with you?" And he took me out to this hotel that was being remodeled. And this was their version of using putty pads. Now, keep in mind, we have to completely cover everything, right? We have to have that sealed. We have to bring it over in front of this mud ring so that when the drywall goes up against it, it seals to the drywall. Well, that's what the side looked like. How much is that really going to help in a Firestop application? And this was some existing construction and some of it was new. And I don't disagree that it's very difficult to do, but that's not doing what it needs to do. And if you can't do what you need to do with that product, well, guess what? They make other products. And here they got box inserts. And now I'm personally fond of box inserts because guess what? They can't fall off the box. They're in the box. And as long as you get the right one, it's got enough intumescent material that when it expands, it's going to fill that entire box. And when you read the instructions, it tells you specifically what size box it is. And oh, guess what? It counts as box fill. So when you start counting your conductors, you got to count this if you're going to use it. And it tells you what the box fill is on it. So pay attention to these. These are great. I'm partial to them if I have to use putty pads. They also make another one that goes right behind a faceplate. So, you know, maybe you get the kind that goes behind a faceplate. I'm not partial to those only because what happens when painters come through? They remove the faceplates. They look at it. They think it's just some gasket. They don't understand what it is. They come back. They throw all the faceplates in a big bucket. When they come back, they put the faceplates back on. And you really think they're going to know which ones needed those putty pads under the faceplate? Probably not. So then you have listed electrical boxes. And so here we got a nice molded, allied molded box. It's not plastic, it's a fiber material, but it's a non-metallic box. And the building code lets us use them if they're listed and installed per the instructions. But when I look closely at this box, I see this label that says classified UL 2-hour WC. This is where I'd ask another question and try to get people to raise their hands. But in this case, obviously, it's a rhetorical question. But how many people truly believe a non-metallic plastic or fiber box is good for 2 hours? It's not. There's caveats that go with it. It's part of that recipe that we talked about earlier. You can't just put the plastic box in a wall and think you got a 2-hour rated box assembly. You got to pay more attention to it. So this is where you have to start asking, show me the installation instructions for the box. Because again, if one box was good for all fire rated assemblies, why does somebody like Carlon and Allied Mold, why do they make hundreds of different box styles for fire ratings? Why would you want to spend your money to do that if one was good for everything? So they're not one is good for everything. So you have to get the right one. And here in red, it tells you that it has to be installed in accordance with the instructions included with the listing. Again, you have to have that not more than an 1/8 inch gap. And then it tells us that boxes on opposite sides of the wall have to be separated by one of the following. And again, fire blocking, horizontal distance, protecting with listed putty pads, or other approved methods. But here's where the catch comes in. And if you've accepted these in the past, you know, ignorance is bliss, right? You didn't know you were wrong. But with that said, here's what you should have asked for. Show me the listing. And in this case, that specific box that we just showed says that it can't aggregate more than 100 square inches within 100 square feet. No single opening can be greater than 22 inches. Well, that's more than what the metal box could be. The metal box can only be 16 inches. But here's why. it's limited on opposite sides of the wall. It has to have a horizontal distance of not less than 24 inches. Oh, and guess what? In walls containing 3.5-inch thick mineral, 2.5 pounds per cubic foot mineral insulation, I can reduce that down to 3 inches. Or in walls containing 3.5-inch thick fiberglass insulation at 0.7 pounds per cubic foot, I can reduce that down to not more than 6.5 inches on center. So I can reduce the space, but guess what? I still can't exceed the 100 square inches within 100 square feet. So these boxes have some caveats. It's not just throw it in the wall and I get my fire rating. When we go to 714.5 for through penetrations, again, it tells us the through penetration has to be protected by one of these systems, either an entire horizontal assembly, again, tested to UL 1479 or ASTM E814. And we have similar exceptions, in this case, the annular space protecting material or concrete, grout, and mortar. So it tells us in these horizontal assemblies, now we're talking a ceiling, a floor ceiling assembly or a ceiling attic, but a horizontal assembly. A lot of times your exit corridors will have horizontal fire ratings to maintain the rating of that exit corridor, or if you're an area of refuge, you're going to have some of these requirements as well. But it tells us that these through penetrations, well, they have to have an F rating. Oh, and they have to have a T rating, and we'll talk more about what those are in a little bit, of not less than 1 hour. Notice that our membrane penetrations didn't have to have those because they're not passing completely through the assembly. They're only doing one side. And so you don't have to have a F rating or a T rating in those applications because the fire can't pass all the way through because it's not a hole all the way through. Or in the T rating, and we'll talk about that later, but you don't have the ability for heat to transfer through a product. So in your membrane penetration, so again, one side, it shall be protected as follows. Your recess fixture shall be installed so as not to reduce the fire rating of the resistance. And then we look here, and we got typical drop-in ceilings. And if you haven't seen it yet, believe me when I tell you, they do have fire-rated grid ceilings. And there's clips that hold everything down, and the tile is a heavier tile that gets clipped in place, and the runners are a heavier material to keep that fire rating. But look at the picture here to the right. There are dimensions as to how these products can penetrate a wall. And the best I've ever seen is a 45-degree angle. That's in the wall at a 90-degree angle. And then when that clean out has to be worked on, what do you think the plumber is going to do? They're going to dig out all that fire caulk, and you think they're going to put it back in? Probably not. But irregardless, that there is no membrane penetration for this application. They put it in the wrong place, and technically you don't have a fire stop there. So with that said, that is not a proper fire stop. Now I know that's the plumbers that have to deal with that, not us as electricians or electrical inspectors. But if you see that as an electrical inspector and you're aware that it's wrong, my suggestion to you would be to pick up the phone and call your plumbing inspector and say, hey, I'm out here on job so-and-so, and I just saw this. I want to bring it to your attention. Make sure you catch it when you're out here. Now, they do make covers that can go over those recessed fixtures, and we'll give you a manufacturer here in a second, one of several that are UL listed. But again, just putting a cover over it, even though it has a fire rating, you have to follow the instructions of those covers. And we'll show you some examples of that here in a few slides as well. There are some exceptions with the horizontal assemblies. If it's less than 100 square inches within 100 square feet, metallic penetrants may be either fire stopped or fire blocked. Again, the same steel electrical box with the prescriptive requirements. listed electrical boxes of any material per their listing, sprinkler annular space, non-combustibles cast into concrete which do not penetrate both sides. Notice, not penetrate both sides, because if it penetrates both sides, we've got a heat transmission issue that we'll talk about in a little bit. And then your sealing membrane of 1 and 2 hour rated horizontal assemblies may be interrupted by a top plate of a wall assembly. And that's part of construction. But when we're dealing with, say, not or wood frame construction, we're going to generally have a double top plate. And nominal lumber constitutes a fire block per the building code. When we get into 714.4.3 and 5.3, non-combustible penetrants shall not be connected to combustible penetrants beyond the point of the fire system. So let me ask you this question. How many times have you heard somebody say, I'm just going to put an EMT sleeve through there. I'll do 12 inches on either side, and then I can convert back over to PVC, whether it be electrical or plumbing, or, you know, I'm going to put a piece of copper through there, and I'm going to switch back over to ABS once I get 12 inches past that fire assembly. You ever heard of that or seen that? No, you can't. Here's the code section that says, again, those non-combustible penetrants shall not be connected to combustible penetrants beyond the point of the fire system. What happens is those metal penetrants that you're using as a sleeve or whatever, they get hot. And then they transfer the heat to the non-combustible, which is usually a plastic material, and it melts. And then it opens up that opening and allows the fire to get through. It also says penetrations and smoke barriers, they have to have an L rating. And an L rating is an air leakage rating, and we'll talk about that in a little bit. And it tells us what our max CFM is based on the square foot opening versus the amount of square foot wall area. And then we have our requirements for those curtain walls. And again, this was one of the reasons all those people died in that MGM Grand fire in Las Vegas about 30 plus years ago now. But again, this is why you have to check these issues before they put their sealant in. Notice that it says the fire joint system shall be securely installed in accordance with the manufacturer's instructions and the listing criteria. Ask for the instructions and read them. Here's the thing, if you ask for them and the contractor can't give them to you, guess what they probably didn't read? And if they didn't read it, guess probably what isn't installed correctly. And we're talking a serious life safety issue with this fire stopping. It also goes on to tell us for curtain walls that, again, they have to be tested, but not to the same standards that we were just discussing. These are ASTM E1966 or UL 2079. And if you have a non-symmetrical wall joint, it has to be tested with both faces. It shall be the shortest duration from either of the two tests. So now we're going to get into the NEC. And we're going to come back to the building code. Don't think we're done yet. We're going to come back to it. But here's what the NEC says in very basic terms. If you break a hole in a fire-rated space, it shall be made so that the possible spread of the fire or products of combustion will not be substantially increased. And oh, by the way, those openings that we put in there, well, they have to be designed and put back so that they resist the fire. They shall be fire stopped using an approved method. Now here's my dilemma, an approved method. Everything in the building code said it had to be a listed system. Here in the electrical code, it says an approved method. What does approved mean? Approved means acceptable to the authority having jurisdiction. That's how it's defined in Article 100. So if you accept fire caulk, even though it may not be the right product, you approved it. I can't speak for your jurisdictions because I don't know them that well. But if you're still one of the jurisdictions that goes under sovereign immunity, don't believe it. Because if you think you're protected from any type of criminal issues or any type of civil lawsuits based on your judgment because you're a government employee and you think you fall under civil or sovereign immunity, do yourself a favor and do some really good research. Because there's case precedent out there that even under sovereign immunity, if you're found negligent or malicious in your decisions, you can be held accountable for that both civilly and criminally. So do yourself a favor and check that out. As an AHJ, and Jeff Simpson as well, we were sued as AHJs. Now, we were both exonerated, and in one of the cases, him and I were both named in the same case. I was sued 3 different times in 8 years. I think he was sued twice in his tenure with the city of Peoria in Arizona. But we were exonerated because they couldn't prove that we were grossly negligent or malicious in our decisions. But if they can find that, trust me, sovereign immunity will not protect you. And to this day, I still carry $1 million umbrella policy because one of those lawsuits went after me civilly, not just as a city employee, but came after me civilly and was going after all my personal assets as well. So this right here, that's a 2-hour firewall. Guess what it is now? A 0 firewall. And how many times have you heard the term, we're going to fire tape that? Drywall mud is not a fire or a product that can maintain a fire integrity. What they're going to wind up having to do on something like that is take those cables out and cut a piece of drywall, and it'll take an engineering judgment. And they're probably going to make them go 4 feet on either side so they can get to other studs. They're going to have to go 4 feet above, 4 feet below, mask it to the wall, screw it to the wall, and then properly seal the hole that they cut just for the conduit to go through with a proper annular space. There's no fire caulk that's going to fix that. So when you see something like that as an inspector, you let them know they breached it, and you let them know you need an engineering judgment on how it's going to be fixed. And they're going to have to find a fire protection engineer that will give them an engineering judgment, or they're going to say, no, I'm not going to give you an engineering judgment. Cut that whole wall out and put a full sheet of drywall in with the proper hole and seal it appropriately. Now, this looks a heck of a lot worse than it really is. This actually is a code compliant installation. This is going to be a 4-hour shaft through a multi-occupancy building. This is a 4-story building, and it's wood framed, as we can see. But if you look closely here, you can see there's about 4 or 5 layers of drywall. And you got that all the way around, and all they're waiting for now is to put a piece across the front to seal that up. So that would be the final puzzle, but the final piece of the puzzle. But this is a 4-hour rated shaft for all those SE cables to go through for this multi-family / multi-occupancy use. The first floor was commercial. The 3 floors above it were multi-family. But the key here is, and this doesn't necessarily fall on the electrical inspector, it's going to fall more on the building inspector. When you put these layers in, there's requirements in some cases, depending on the system, that you have to stagger the joints, you have to stagger the screws. The lower levels may or may not have to have all the joints properly taped. Sometimes they do, sometimes they don't. The joints will have to be staggered 12 to 18 inches, so you don't have joints one right over the other. So, but that's going to be a detailed inspection that the building inspector is going to look at. And he's going to look at each one of these layers as they go on. They're going to put the first layer on, and he's going to, I say he is a euphemism. We have female inspectors out there as well, but the inspector is going to look at it, and they're going to look at the screw pattern, and then they're going to see if it needed to be properly taped. And then the second layer is going to go on. And they're going to look and make sure that they staggered the joints on the second layer so they don't directly overlay the first layer. And any joints that have to be taped in the screw pattern. And then the third layer goes on, and they do the same thing. So this is a multi-step inspection process.
Hey, so, Jeff, may I ask a question? Sorry about that.
Yeah, go ahead, Robert.
The previous slide you just had.
Yep, let me back up to it.
All right, you said it's code compliant. Just curiosity, 300.19 of fire-rated cables and conductors vertical supports. Is that installed somewhere in there?
Yeah, so the vertical supports are going to be a requirement based on the length of these conductors and how far they go. You still have to support this SE cable appropriately. When I said a code compliant, I'm talking from a fire rated perspective, not necessarily an electrical code perspective. But yeah, you're going to have to support these. If what I would go into Article 338, what are they, like every 6 feet on center, I believe?
Yes,
So,
338, yes. Uh-huh.
yeah, so they're going to have to support these SE cables as what's in 338.30.
And
I
also,
was just talking about it from a fire shaft perspective.
yes, sir. Thank you. I appreciate that. I was just looking at 3.9 for the vertical installation as well. Thank you.
Yep, no, thank you for bringing that up. You know how hard it is to find a picture that's 100% code compliant when you're trying to do presentations?
Understood, yes.
Yeah, no, anybody who's done them knows exactly what I'm talking about. All right, so here's some examples. Here's some cable tray, and here's some properly installed fire systems. I can tell you that if I was still an electrical contractor, that I would exclude fire stopping from the bids on my jobs, and I would make the general contractor hire a fire protection contractor to go through and seal all of my penetrations. And honestly, I think all trades should do that. Fire protection is such a specialty that generally an electrician and electrical contractor don't understand it well enough to do it properly, as well as a plumbing or a mechanical. And in most cases, even a lot of building contractors don't understand it well enough. There are people that specialize just in fire protection. And my suggestion, if you're a contractor listening in today, is if you have the ability to exclude fire penetrations from your bid and put that onus back on the general contractor to have a fire protection contractor come through and seal all your openings. So in 410.115, it talks about luminaires, and that's where we have a lot of issues is with our recessed cans that penetrate, whether it be a troffer or whether it be a typical recessed can. And it tells us here in 410.115, for fire resistive construction, where a luminaire is recessed in that fire resistive material in a building of fire resistive construction, a temperature higher than 90 degrees C or 194 F, but not higher than 150 C or 302 F, shall be considered acceptable if the luminaire is plainly marked for that service. And here you can see, here's an IC can that is a fire rated IC that's got a 2-hour fire rating. You still have to make sure it goes in the right assembly and everything else, but here they do make fire rated luminaires, but unfortunately, you don't see them very often because the contractor generally misses this part of their bid. And then if they had to actually put these fire rated cans in a large project, it most likely will bankrupt them because these aren't cheap. And if you have a lot of them, it's going to be pretty pricey. So what they would generally opt is using a regular recess can and then using a product like this tent mat right here, which is a fire rated material that just kind of canopies over the can. And these themselves have limitations as well. You can see what I've highlighted in the light red, and that's clipped from the instructions that we can see to the left of that. And you can also see what I've underlined in black, and it tells me that these can covers are good for a 1-hour fire rating when used in an L500 series floor ceiling design. So they're limited only to the L500 series floor designs. You have to have solid wood joists. You could have open web joists, but the max on center is 16 inches. You have to have a minimum 1/2 inch thick gyp ceiling. And the number of luminaires, well, they can't exceed a ratio of more than 1 per 25 square feet with a minimum separation of at least 3 feet. So we have all these rules that we got to play by. So when you run into an inspection like this, and this was an apartment complex, I'm going to tell you those look like they're closer than 3 feet apart to me. But when they get called on the fact they didn't have fire rated cans, they just went out and bought a bunch of these. They didn't read the instructions. And you can see here, there's a UL classified mark. They didn't seal any of the openings where the cables go in, which we have to. Again, we can't have more than 1 per 25 square feet. We have to have a minimum of 3-foot separation. We have to look at this floor ceiling assembly and make sure it's at L500 that we were just talking about. But I hate to say it, but they went and paid a lot of money for these box covers and they still can't pass code. They didn't do it right. So again, if you're a designer listening in, my suggestion would be to design your building to have a false ceiling. And why I say that is, if we drywalled this underneath here and then had a false ceiling down below, when these cans penetrated that false ceiling, they don't penetrate the fire rating. And you're fine. It's when you penetrate the actual fire rating that we have the problem. Now, I've been in construction long enough to know that, you know, space is money, and over designing and stuff becomes a problem. You may not have the space. I've been in many jobs as a commercial electrician that they kept dropping the ceiling height because they didn't overlay their drawings. And by the time they put mechanical and plumbing and chiller lines in that ceiling, they didn't even have enough for a 4-inch troffer to lay in there. They had to drop the ceiling height like 6 inches, sometimes 10 inches, depending on the size of the troffer, so you could have enough space to weasel it up in and then drop it back in the ceiling. So I understand that that happens, but in my mind, that's poor design.
Can I ask one more question?
Yeah, go ahead, Robert.
Would this fall in line with 314.25B? We have exposed combustible wall or ceiling finishes where aluminum canopy or pan is used, where it actually has to be covered up in 410.23. Is that, being this is a combustible ceiling, even if you put drywall in it, would that still fall into play with there?
Well, remember your IC can ratings, and what is it, somewhere in 410?
410, not IC and non-IC.
Yeah. So remember your IC and non-IC can ratings. If it's IC rated, it can be in direct contact with combustibles. And it's part of its IC rating is it's listed not to get hot enough to cause those combustibles to combust. Okay. If it's not IC rated, then 410 requires us to maintain a minimum of a 1/2 inch from combustibles and 3 inches from thermal insulation. So from an IC can perspective, those are the rules we're going to play by.
Gotcha. Okay, thank you.
You're welcome. So big NO, no, this is not a proper installation. Even though they got those fire rated canopies, they didn't follow the rules that those fire rated canopies are tested with. So one of the things that you can use, and hopefully Jeff has schooled you guys, and I say school as a pleasant term, but has schooled you guys on what product IQ is. And UL product IQ, and we'll go through some stuff at the end of the presentation here in a few slides, but product IQ is available for free, and it gives a lot of information to both inspectors and contractors. If you're an inspector, you get the paid version for free. If you're a contractor or a designer, there is a paid version that allows you to save searches and do other things and get documents, but there's a free version for everybody. It just doesn't allow you to save your searches or print documents and that kind of stuff. But here you can see that we have, when I put in the guide card, CDHW, it allows me to show that I got 20 different US certified manufacturers of products used in fire rated assemblies for luminaires. Some of them are enclosures like that tent mat, and some of them are actual listed fixtures like that one we saw that had the big red cover around it.
Jeff,
So,
I have a question.
Oh, I'm sorry, go ahead.
Does the sprinkler systems make any difference?
No, not as far as penetrating the fire barrier, no. The sprinkler system will give you some relaxation in some cases where it may have to be a 2-hour and it can be reduced to a 1 hour. But just sprinkling the area, if it's a true fire rated horizontal or vertical assembly, it still has to maintain those integrities. The sprinkler doesn't relieve you of those requirements. So when you're in Product IQ, all these blue items are links. And because I showed you a tent mat product, I'm just going to show you what comes up when you click on that link. And here again, we click on that link and we see tent mat and we read it, and they have like 5 different ones. I just can't fit them all on the page here. But you see, again, what I highlighted before, it tells us here, it's good for a 1 hour. It's good for the L500, solid or open webs, 1 per 25, not closer than 3 feet. We blew it up down here so you can see it a little easier. But those are the requirements that product is certified under. So if you violate those requirements, you still don't have the rating that you're trying to achieve. So here is how that product would be marked. And this is that category CDHW. And it tells you exactly how it's going to be marked. So when we had those ones in the ceiling and I showed you that little white UL classified mark, this is all the information that is going to be on that. And it's going to tell you very clearly what design number that has been intended to be used with. And we'll talk about design numbers here in a few minutes. So also in Article 770, when we're dealing with optical fiber cables, we have a requirement here. Now the general requirement in 300.21 would still cover Article 770, because keep in mind 90.3 says chapters 1 through 4 apply generally. 5 through 7 are your specialties and may amend or modify the general requirements. And then it tells us that when we get into chapter 8 is a standalone chapter. And we can't go back into any of the other chapters unless 8 references us back there. So we really need to have special fire stopping requirements in chapter 8 unless they had a general reference back to, say, 300.21. But here in 800.26 for communication circuits, you can see again, basically, if you put a hole in it, you got to fire stop it. We see it again in 820 for communication, broadband radio applications. If you put a hole in it, fire stop it to maintain that rating. We see it again in 830 for broadband communications. And we see it again in 840 for power broadband applications. Now, we just saw this in 4 different Chapter 8 articles. And that's one of the reasons in 2020, they reorganized Chapter 8, and now Article 800 has all these general requirements, and then the specific requirements are in the respective other articles. So when you get to 2020, all these fire stopping issues will be in the Article 800. The new Article 805 is what 800 used to be, and then all the respective articles stayed the same. But all your common requirements throughout Chapter 8 are all now consolidated in Article 800 for the 2020 NEC. So here's some examples of complying with all of these Chapter 8 requirements. And again, making sure that we get the right fire stopping. And some systems, not all, but some systems like we see here in the bottom right, require that you identify what that system is. But you want to make sure you got the proper system for the application. These ones up here, they're actually pretty nice. They're a 2-piece. And you can see the different fins, so they'll fit with different thicknesses of wall. But you don't have to cut the cable if it's an after the fact. As long as the hole is the right size, you can go ahead, and these are 2-piece. You snap them over and then you push them in the wall, almost like a snap-in KO, basically. So getting into the mechanical code, I don't know if we got anybody that are combination inspectors on here, but we're just going to touch briefly on these other codes. But you can see in the mechanical code, they still have a requirement that if they punch a hole in a fire-rated wall, they got to properly seal it. And here's an example of a fire smoke damper. The mechanical code has requirements for accessibility so that you can get up and inspect it after the fact. This is a scenario where you're probably going to have L channels because this is going to have some movement. But this is a scenario where you don't want to use an intumescent fire caulk to seal that, because if you do and it tweaks that sheet metal, then your dampers aren't going to close when the system tells them to close. You get into the plumbing code, again, you put a hole in it, you got to seal it. Here's some examples of different plumbing systems that would have to be sealed. One of the more common ones is this little water box for your refrigerator, ice maker and stuff like that, water and ice. A lot of times these will get put in a common apartment wall, and they want to use the ones that aren't fire rated, but oh, guess what? You pay a little bit more, you can get the fire rated ones, but they generally don't realize what they're doing. Hopefully that's the case. And they'll put a standard one in, and you just put a big hole in that firewall. Again, when you have these collars, make sure you anchor them, because otherwise the weight of this plastic, especially as it starts to melt and you may not have a support directly close to it. One of the requirements for this is you have a support directly close to it, but you may not. And then the weight of this, as it melts, it'll pull away. And if this isn't properly anchored, it's going to pull this away with it, because as this starts to expand, it's adhering to that plastic. Same thing up here. That's just drywall. What do you think the likelihood that there's really a backer board behind there versus those are just drywall screws with maybe plastic anchors? If you get into the fuel gas code, same thing. You put a hole in it, you got to seal it. But look at here. The gas guy, they did their job right. They identified it. But what kind of fire shield do you think we have here with all these cables going through? And what about that drywall mud? What kind of fire rating do you think that drywall mud is? So here you got somebody who spent some money and did it right, but to what end? The wall is still breached. So the fire is not going to get through the gas line, but it's dang sure going to get through this when it dries that drywall mud out and breaks, and there's about a 6-inch hole there. It dang sure is going to get through here where there's not even fire stopping or anything. They just put a little bit of fire caulk on one side, but left the whole backside completely open. If you get into the International Property Maintenance Code, this puts the onus on the property owner. So if you go into an existing building and you see these issues, even if they're not done by the contractor, if they're existing and the contractor has nothing to do with it, technically you can't hold a permit up for violations that aren't under the scope of that permit. Now, depending on your local ordinances and any amendments you may have to your local codes, but in general, you can't hold a permit hostage for violations that aren't within the scope of that permit. But if you've adopted the International Property Maintenance Code and you go in to do a ceiling inspection and you see a bunch of holes in the drywall like this, but it has nothing to do with what the permit you're there for is, you can still write a correction under the International Property Maintenance Code and give it to the building owner and say, hey, these need to be fixed. And until you get them fixed, we can't final this out, because I can't give it to your contractor, but I'm not going to give a C of O to a building that I know is unsafe. Now you get into the IRC, International Residential Code. And again, it tells us that if we have these fire ratings, and we do in residential, generally, in a nutshell, the easiest way to explain it is any place we have a horizontal to vertical change in direction. So at your ceilings, at your box soffits, at your eave overhangs. If you have balloon framed walls, then there's some additional ones in your balloon framed walls, but generally any place I go from a vertical to a horizontal. So my top plate into my floor space all have to be fire stopped. That's it in a nutshell. It's not all inclusive, but it's good enough for what we're talking about today. And so all of these places here, we need to fire stop that. And we'll talk about how it can be done. We need to fire stop that. Here we got a drop ceiling in the hallway. So this wall cavity can communicate to the floor space. We have to fire block right along there. Here we got a double wall configuration. The residential code requires that to be fire blocked. Another common place is chimney chases. If you have either gas or wood burning fireplaces, those get missed all the time in residential construction. So going back into the building code. Does somebody have a question? Okay. So going back to the building code, 703.7, marking identification. So this is something that's fairly recent, maybe in the last 2 or 3 code cycles, and I think this is a great change. And it tells us here that we have to mark these fire rated spaces or these walls. And when I have them in a concealed space or an attic area, they have to be marked and shall be effectively and permanently identified with signs or stencils in the concealed space. And it tells us they have to be located within 15 feet of each end and 30 foot on center. And it tells me what I have to say. It has to be in 3-inch letters, 3/8-inch brushstroke, contrasting in color. And it tells us we have to have wording like fire and or smoke barrier, protect all openings, or something equivalent. So this now at least says that when somebody goes in after the fact and punches a hole in for a retrofit of some sort, that they know they just put a hole in a firewall. Because, you know, 3-4 code cycles ago and farther back into the past, without that marking, people a lot of times honestly didn't know. I mean, think about when you went through your apprenticeship program. Did they teach you about fire stopping and what a firewall was and how to recognize a firewall and where they had to be? They sure didn't in my program. I was educated through correction notice. That's what I call it, red tag, education through correction notice. So here you can have any of these. It doesn't say you have to have anything specific. You can stencil it on if you want to. Here's an example of a stencil. As long as it meets those 3-inch dimensions and 3/8-inch brushstroke, you can stencil it on. But again, look at here. We've got some MC cable that goes through there with some fire caulk. Looks like we're using some MC connectors going in. We got another MC going through here. Looks like we got a bunch of fire caulk going on here. But hopefully this sign or this stencil right here lets people know when they get up here that, hey, if I'm coming in to do a cut-in box and I got to punch a hole in here and drop down this wall and put a box in, hopefully that tells me, hey, that's a fire-rated wall. I got to make sure I seal that back up.
Is that sign required in the building code, or did the contractor just put it up there for courtesy?
No, in this case, it's required here in the building code, Robert, in 703.7.
Okay, I missed that. Okay. Mm-hmm.
Yep, not a problem. So here again, we can see, go ahead, I'm sorry.
Can you offer us anything for guidance, since we are not structural engineers and not fire protection engineers mostly? David Engelhardt may be an exception there. But in existing buildings where we don't find that sign, can you give us some guidance as to where we might find a wall should have an hour rating or 2-hour rating?
So in larger commercial buildings, not so much your multi-tenant strip plazas, because they can all fall under one occupancy per se. But where you have large buildings, multi-story, you're going to have to start having floor ceiling separations. When you start having stairwells, like in hotels and motels that are exit stairwells, your exit passageways, your exit corridors, your exit hallways, those are all almost always going to be a minimum 1-hour fire rating if it's sprinkled. If it's not sprinkled, a 2-hour fire rating or higher. When you get into high rises, of course, education facilities, not necessarily universities because they're considered a B occupancy, but your elementary schools, your high schools, your middle schools, they're going to have a lot of fire rated separation walls in those occupancies. But generally, if it's made of masonry, or it's you get above the ceiling where the paint is and you see that it's a type X 5/8 drywall, they didn't put type X in there just because they thought it was a good idea. You know, type X is a fire rating. They're going to use a non-fire rated product because it's cheaper. But when you start seeing masonry walls built, that's a good indication. So here's one. This is drywall. You can see how they brought these conduits through. And you can see how they puttied this all in. I don't know if that's correct or not. Somebody's going to have to show me the installation instructions that putty, even though it's tooled in really, really nice, they're going to have to show me that that's good for that size opening with this wall system. And the same thing here. Now, here's an interesting, we puttied this hole, but look, we got this conduit stubbed out probably for a future data cable or something with the hole wide open. What is that doing for the fire rating of that wall? So here's another one. You can see the guy's doing a really nice job tooling it in. You can see there's markings underneath that details out what that system is. But you still need to look at this and make sure that that's the right system for that wall application. And then remember we talked about earlier metal objects passing through a wall. How many of you have ever cooked with a cast iron skillet out on a campfire someplace? You let it go for a little bit. Bet you only did this once. You reached and grabbed that handle and realized it was super hot and didn't do that again, right? You started using pot holders or you took your sweater because it was a chilly night and you wrapped it up real good and put it on the handle and picked it up. Well, that EMT is going to do the same thing. When you have that fire on one side, it's going to get hot and it's going to transfer that heat just like that cast iron skillet did. And that heat's going to go through that wall. And so you got to make sure that on the other side of this wall, there's not piled storage or combustibles that conduit's going to come in contact with, because otherwise it's going to ignite something on the other side of the wall. Even though it didn't necessarily breach this wall, the heat transfer got to be such that it caused a fire on the other side of the wall. So we'll talk about how we mitigate that in a little bit. So when you have high rises, and I wish all systems had this, but right now it's only specific to certain buildings. But here it requires a special inspection. And not to take away from anybody on this call, myself included, I know quite a bit about fire stopping, but if I had a choice of allowing a special inspector to do it, I would gladly give them that option, because I don't want that extra liability, and God forbid I miss something, right? When we're talking about this kind of safety requirement. So in my mind, I think all fire stopping should be special inspected by somebody who's specially trained in fire stopping. But with that said, the building code in 1705.17 does require that if I'm in a high rise or I'm in a building with an assigned risk category of 3 or 4, special inspections for through membrane penetration fire stops, fire resistant joint systems, and perimeter fire barriers are tested and listed in accordance with the other sections that we already covered, shall be in accordance with 1705.17.1 or 1705.17.2. So here you got a code mandate that somebody that is a special fire stop inspector is responsible for doing those inspections. Now, in my mind, it's really no different than the code requiring high strength bolting special inspection or welding special inspection, or if you're doing CMU masonry, they have a special inspector go out and make sure the rebar is right and the grout lifts are right and the right cells are grouted. And then the inspector of record, the city inspector, or whoever is responsible for the overall inspections, they just read those special inspection reports. And as long as they don't see any deficiencies, then they approve it as well. So getting into the 17.1 and the 17.2, those are your penetrations and your joint systems. And again, it says that it has to be inspected of the penetration and tested and listed, and shall be conducted by an approved agency. So that's up to the AHJ, the city inspector, I guess, or the county inspector, on who they will accept to do these special inspections. But similar to masonry, similar to welding, similar to high strength bolting, there are organizations such as ICC that certifies these inspectors in those specialties. So fire stopping, again, UL 1479, 1479 or ASTM 814. Here's what those ratings mean. I told you we'd get to them later on. So F is your flame occurrence, and the F rating is based on the flame on the unexposed surface. During testing, if the flame is on one side of the wall, the other side of the wall cannot exhibit any flame. There can be some smoke and a little bit of soot that comes through, but no flame can actually make it to the opposite side of the test. Your T is your heat transmission. And again, we'll talk about T ratings. And that is that temperature transmission. And that goes back to that EMT that I was just using it as an example. And it says that the T rating is the amount of time for the surface of the penetrating item on the non-fire side to rise to 325 degrees F or higher. And that's what your T rating is. So you have to use metals and stuff on certain systems, and we'll show you some that will require a T rating. So when you have those T ratings in the system, and again, that's why it's so important to ask for the system they're using and look at those details. If you can get them put on the approved set of plans, that's much better. But if they're not going to be on the plans, they need to be at least in the field. L is your leakage, and that's optional depending. Now, when you get into some HVAC requirements, some air duct systems, there are going to be some leakage L requirements, but that's based on how much air can pass through that fire sealed penetration. And when you think about a smoke fire damper, when it's in the closed sealed position, they're going to have L ratings. And then your water leakage, again, is optional depending on the system. Some will have W ratings, but that's saying that if it were to get wet from a sprinkler system or a plumbing leak, that's not going to cause it to prematurely fail. So in your F ratings, and here we see a system, and we'll tell you how to identify these systems in a second. But here you have the passage to prevent flame and to maintain the structural integrity is determined by the hose stream test. And in this case here, this one, we can see it over here with the whole system, but I blew it up to make it easier to read. It has an F rating of 2 and 3 hour, but we got to go down to item 4 because item 4 is going to detail when it's a 2 hour and when it's a 3 hour. When we look at T ratings, and in this case, this system again has a T rating, but guess what? It has a 0 hour T rating. So if you're using this in an installation that needs to have a 1 or 2 hour T rating, this is not the right system to use. This one also has an air leakage application, and it tells you you got 2 different air leakages. You got ambient temperature. David, did you have a question? Okay.
No, I'm sorry. I'm transferring modes here. I'm sorry.
Okay, no problem. I just saw it looked like you're trying to ask a question. So here we got L ratings for air leakage, and we got L ratings for a 400 degree temperature. And so you can see that you got different ones. At ambient temperature, it's going to be 4 CFM, but at 400 degrees, it's going to be less than 1 CFM. So this one does have an L rating. It doesn't have a T rating, but it's got an L and an F rating. So your W ratings, again, incidental water exposure. We have a leaky plumbing fixture or a sprinkler line or something that gets this wet, and that being wet in itself isn't going to degrade it and put it into a potential failure. So how we establish our F and T ratings.
Can I jump in here for a moment, Jeff, please?
Yes, go ahead.
Yeah, we're getting close to the end, depending on how many questions there are. I mean, if you may not know this about our particular group, but we often are happy to keep going because we're learning. But since we're getting to this point, I'm going to invite people to again go to chat and to just tell us, name a jurisdiction you're licensed in, or saying I'm not licensed. If you're a member of IAEI, that will assure that if you've been here from the beginning, you get your 2 hours of CE. And I'll also invite people who go to the chat to see Brian Holland, particularly NEMA rep and very knowledgeable man on electrical history, is with us, and he's been posting some links to useful information that you might want to jot down or copy. Aside from that, if I've looked, I can see some of the people here, but if you can use chat to just show up over the next few minutes so that we can affirm that you were here and earned your CE. And then we'll let Jeff get back to this. And at the end, I'll have an announcement or two. Thanks, Jeff.
Well, thank you, David. And Brian, thanks for putting those in the chat. I didn't realize you were here, but thank you so much for doing that. So establishing your F&T ratings. Here's an example of a full-scale wall test. And these aren't cheap, so we try to do multiple tests at the same time. And here's a insulated pipe going through a gyp wall. And be careful when they call for like this insulated pipe, make sure they're using the right insulation, because if they're not using the right insulation, it's going to fail the test. And so we test exactly the way the manufacturer says to put it in. We follow the recipe to a T. If you don't follow the recipe to a T, there's no guarantee that that system is going to hold when it really, really needs to, when it's important to. So here's another example of concrete going through a floor. Again, T ratings may be of concern depending on the type of construction that we're dealing with. Here's some cable tray going through a concrete floor. Here's one of those collars. And again, notice how this is anchored. It's anchored to a concrete floor with those hammer-in type expansion anchors. So you want to make sure that you're using the right ones. Maybe Tapcons aren't going to be okay in this case. Maybe the Bulldogs, as I refer to them, but the 1/4-inch hammer lead-in anchors, they probably are going to melt. Lead's a soft metal. So if you hammer these in with those 1/4-inch hammer-in lead anchors, it probably isn't going to hold. So making sure that it's properly secured. Here's an example of what would be a wood ceiling floor application, a floor ceiling application. You can see there's a bunch of non-metallic cables, some MC cables, copper and EMT going through there. Here's a more expansive view of the NM cables going through. And again, I'm not saying anything about fire caulk. I'm not saying you can't use fire caulk. Fire caulk, when used properly, is appropriate. Here's what they do based on the time of whether it's a 1 hour, 2 hour. In the first 5 minutes, it gets up to 1,000 degrees Fahrenheit. In the first hour, it gets up to 1,700 degrees Fahrenheit. And then you can see gradually from hour 1 to hour 4, we slowly cook the oven up and get it to 2,000 degrees Fahrenheit. Here are some illustrations of a test. Here's the bottom side. You can see how melted away everything is. But if you look at the top side, it's still intact. There's a little bit of smoke residue that got through. This is a piece of pipe. You can see a little bit of smoke residue, but it stayed intact. That's a post-tension slab, and that passed the test. Immediately after the test, it gets hit with a 2-inch hose stream. While that thing is hot, you can see the steam coming off it. They bring it out and they hit it with a hose. It still can't fail under the hose stream. It can't blow out. If it blows out, that's putting air back in. That's fuel to the fire. So we've all had scenarios or known of scenarios where a fire was put out and an hour or two later, it spontaneously recombusted. It caught fire again. If those holes have been breached because of the firemen putting the hose to it, that just lets that fire spread throughout. Meeting your T ratings. And we talked about that EMT example. And so here we got to worry about the transmission of temperature. And there's different ways to take care of that. We can use different collars that become like heat sinks. You can insulate the penetrant so that they don't transfer the heat through. So obtaining your T code, there's different ways. You can wrap the metallic pipe in a mineral wool or some kind of ceramic insulation, like the upper right picture here, or they make heat sinks basically, like we see an example in this product here that has a heat sink collar with a thermal pack that goes in. You put it around, you hold it on with some stainless steel hose clamps or pipe clamps. So they got these different type of collar heat sink systems out there. So pay close attention to, don't arbitrarily think that a metal penetrant is automatically okay if it's completely sealed tight to the hole with poured concrete or grout mix or even fire caulk. Check your system. If you got a T rating, you got to make sure that you meet that T rating for that application. We talked earlier about product IQ. This is what it looks like if you haven't got into it yet. I strongly suggest you do. You can access it from any data or Wi-Fi connected device. If you go into your favorite browser and just type in product IQ, it usually is the first thing that pops up, and you can click on it. It'll take you to this page here where you can, if you already are logged in and registered, you can just log right in. If you're not, here's where you can register for free. Again, if you're an AHJ, go through the process of identifying who you are. And once they verify who you are, if you've got a government address, like a city of whatever.gov, they're going to automatically recognize you as an AHJ. If you are a third party AHJ, but you still do inspections and you have a typical Gmail or something like that as your email, they're going to ask you some follow-up questions. You're going to have to jump through a few extra hoops to prove that you're an AHJ. Usually something as simple as a business card or a letterhead or something like that.
If I may interrupt on this,
Yeah, go ahead, Robert.
I'm with Jeff on this. I strongly encourage you to do that. I was investigating a fire pump installation when I reached out to Jeff for some help on a couple of things, and that's when he first introduced me to this. And also I use this for another fire pump actual design that I did, where you're able to get make sure you get the right FHIT system. So it is definitely a good tool to use.
Yeah. FHIT is your wire protection systems, which would be necessary if you're using cables and stuff like that to penetrate. Actually, it does conduits as well. But here's what your homepage would look like. If you go up here, this is just a keyword search. You can type anything in. If you go down here, these are other additional links. And in this case, we're going to use the building link here in a second. If you know the system, they give you these category codes, or they tell you it's an L500 system or an L501. You can type that in and it'll take you right to the system. UL used to publish these directories, and I don't remember how many there were, like 5 or 6 volumes to the fire directories. I think they still publish them in limited edition, but they sell them and they're pretty pricey. But you can get all that information free online. Here's the different categories that are relative to the different fire stopping systems. If you're using duct wrap materials, and that would be something you'd see in a type 1 exhaust hood for a commercial kitchen, for example. You also have duct wrap materials for different electrical systems like cable tray and duct bank applications. You got void, which would be like your fire caulks. You got your fire stopping devices, your forming materials like your putty pads, through penetrant materials. Here's an example, and this is what you should see. And for the contractors that are on the call today, this is your recipe on how to put it together. So if an inspector questions an installation that you put in, you can grab this document and show them and say, look, here, this is a listed system. Here's all the installation requirements. I built it exactly like this document says. And down below here is where the corresponding characters are up here. And this goes down, it's just way too much to put on the screen. As an inspector, this is what you want to ask the contractor for. If they can produce it, there's probably a good chance that hopefully they did it right. But if you ask them for their fire directory or their fire detail on their penetrant, and they give you that deer in the headlights look, there's probably a good chance that they didn't do it right. But in either case, this document works both ways. It's the inspector can use it to inspect by, and the contractor uses it to prove compliance and to show that they put it in the right way. All this stuff is available in Product IQ through the guide information, the design system assemblies. The product categories are indexed by manufacturer, so we don't think that Arlington is a better box maker than Carlon. They're just all done alphabetically. From a UL perspective, if they got a listing mark on them, they're all equal. Now, being a contractor in a previous life and contractors and people that have been, you know, you have your preferred products. You know, some products are maybe better than others, but from a testing standpoint, if they got the listing mark on them, they met the requirements to get that mark.
Hey, Jeff,
Yeah, go ahead.
On Product IQ, do you also identify products that have been listed by other NERDLs?
No, that's a good question, David. Product IQ only identifies UL certified products. Other NRTLs will have their own version, not of a Product IQ, but what's called a certification directory.
Okay,
And you can go to, say, ETL's website and look at their certification directory, and it will tell you what standard that product's been certified to. But with that said, that would be part of our certification directory for only UL stuff. The guide card information that I'll show you some information here in a minute, or these fire directories that we're talking about now, they would apply unilaterally to all NRTLs because that's information from a standard. And so
right.
Once an NRTL says that they complied with that standard, then that guide information relative to that standard or that fire directory detail relative to that standard would be applicable even to an ETL listed fire door, for example.
Okay, so in other words, we got a product that identifies ETL as their listing agency, then you got to go to their website to verify the listing. Then of that
Right,
product.
and then to find out what standard it was certified to, once you know that, then you could use UL's guide information, reference that standard, because the standard is the standard is the standard,
Right.
regardless of whose product mark is on it.
Okay, very good. Thank you, sir.
You're welcome.
I'd like to kibitz that a little bit, going a little deep. One thing is you will find, I have found NERDL marks on products and dug down to the OSHA site and found that, well, you know, that NERDL has not been authorized to test to the standard that I'm interested in using that product for.
That's a good point, David.
And that is a nasty one because it takes a lot of time to dig into this stuff. Another is that NERDLs vary in how careful they are. OSHA tries to keep an eye on this, but they have limited resources. And then, well, the other thing, which is a little hairier, is guide cards. Guide cards do not map directly to what the standard says. They are like an abstract of a research article. And the very knowledgeable people at UL who are responsible for the particular standards do their best job to look in the standard and give us a very short executive summary. But that guide card does not necessarily say, this is it, and this is the only way, and this is what they test. If you want to find that out, you got to open up that standard and look into it and say, do they really look this? Do they really require that if you actually want to know? And fortunately, UL makes those available now. Not for download, but for at least reading.
Yeah, free viewing. And you make a good point with the guide cards too. It's basically the Reader's Digest version because we're limited to what we can put in there just on space alone. Otherwise, we just publish the entire standard, right? So it's basically the Reader's Digest version. Some of the key things that for the most part, installers and AHJs need to pay attention to. So examples of guide card information for fire stopping. It's going to give you a general description. It's going to identify the standard, the ratings, if there's permitted substitutes. Remember, I said this is a recipe. So you can't just arbitrarily substitute. And when we're talking fire rating with walls with drywall, it'll tell you specifically the drywall manufacturer. So if it says that it can only be done by American JIP, you can't use Mexico JIP, or you can't use China JIP. It'll tell you brand name specific what JIP is part of that fire rated assembly. It'll tell you the angle of the penetration. Remember that big plumbing pipe that we showed you earlier that was paralleling the firewall and not going through it perpendicular? I'm not going to say none exist, but the biggest angle I've seen is a 45. So if you got more than a 45-degree angle, you really probably ought to be questioning it. I've never seen anything with the greater than 45, but that's not to say something doesn't exist. I just personally am not aware of it. And then your description number. And so with your description number, we're going to explain to you what that means. And so here's an example. We got a CEYY 1079. What does that mean? If we look here, we see that right here, but what does that mean? We got some information right here about what our FT and L ratings are, but what system can I use this in? Well, this exploded view has all these sub breakout numbers, and down below, it identifies what all that means. But here, C, in this case, C and that CAG, that tells me that this is a good for walls or floors. I can use it in both the vertical and the horizontal. If it only had a W or an F, it would be restricted to that specific application. So here it tells me in my floor and wall assemblies, it's a minimum 4.5-inch thick reinforced lightweight concrete with 100 to 150 pounds per cubic foot. It tells me that it can be up to the construction of any minimum 6-inch thick UL hollow core precast concrete units. And it may also include classified concrete blocks. So your typical CMUs if we're doing a wall application, or if this were a tilt panel. I don't know if you guys see a lot of tilt panels in your part of the country, but out here we see tilt panels on a daily basis. So here's what those AJs mean. The A tells us if it's a concrete that it's good up to 5 inches thick. If it's a wall, it's good up to 8 inches thick. So the AJ is equal to or less than 5 inches, and the walls are equal to or less than 8 inches thick. The number, that's going to correlate to what the penetrant is. In this case, our number was between 1,000 and 1,099. It was 1,079 or 1,079. So we fall in between those two. That's going to be a metallic pipe, conduit, or tubing. So if they're using this system and they got PVC going through there, wrong system. And then the 079, that's just the actual system itself. So here, again, the 1, 2 is going to tell us what that is. And we're going to go ahead and see that in this case, it's going to be metal piping, conduit, or tubing. It can have a 0 point of contact. So remember we talked about whether it had to be placed eccentrically, concentrically, or point of contact. So this tells us I can have 0 up to 4 inches of contact point. The conduit or tubing has to be rigidly supported on both sides of the wall or floor. And then here it tells me what they can be. So if we look at conduit, the max conduit is 4 inches or smaller, EMT tubing, or nominal 6-inch diameter or smaller steel conduit. I can use some flex conduit here. Or if it was plumbing, I could use copper tubing type L or heavier, or copper pipe. So it tells me exactly what that penetrant can be. And then 079, again, is the system number. Each Firestop has specific construction features. It may have various ratings, but the key is if you take absolutely nothing from today's 2-hour presentation, you have to follow it exactly as it's written. No substitutions unless it gives you options. Each product category describes some generic applications. Each product category covers your joint systems, perimeter fire containment systems, and your Firestop systems. Each category contains the manufacturers and the designations of the products tested and specified in the system. again, specified is key. It has to be identified in that system. Manufacturers, again, are arranged alphabetically. We, again, don't think that AB and ABB is any better than Schneider squared E. It's just we do it alphabetically. Product IQ helps give us a way to achieve code compliance. It's updated weekly. It will need a password. They do have a abridged free version without a password. I've never tried it, but it's going to be limited more than even the free version. There's no charge to use it if you want the free version. If you're an inspector, you get the paid version for free. Designers, you may want the paid version so that you can start saving designs and printing them out. UL, even though they're copyrighted, as long as you print them in their entirety, they don't care about, printing them and pasting them into your plan design. Here's the link to get you directly there, or the web page to get you directly there. When you're there, remember we talked about the keyword search, but down below, if you click on the building materials, you get all these. These are all links. We're just going to use Firestop because that's what we talked about. You open that up, you get this, and you can see that up here, if you can read it, there's 7,476 different fire stopping systems out there. We'll blow this up. This is all fill in the blank. If you know the system, you can fill in what you know, and it'll narrow your search so that you're not trying to figure out over 7,000 systems. Again, if you know the specific system, you can go in and type in the system number. And if you do that, it'll take you right there. Again, that's a link. You click on it, gives you the exploded view. When you look at the exploded view, again, all these numbers are correlated. You look down below, and this is what you're going to correlate with. In this case, item 2, the penetrant, is 1 metal pipe. So if they put more than 1 in, they're not using the right system. And then it again tells you a 0 point. It tells you all the information you need here. Here it tells you what the system or what the pipe can be and its size. And then down here, it tells you very clearly what you fill that void with. And in this case, you can either use Metacaulk RectoSeal MC 150 Plus or RectoSeal Metacaulk 1000. Those are the only 2 products. So if somebody shows you this system and they're using Hilti Firecaulk or 3M Firecaulk, wrong system, wrong product, no guarantees that it's gonna give you your fire rating that you're looking for. So if you don't know a system, but you have some parameters that you want to work with, we know we got a 4.5 inch thick concrete slab. We know we're going to use EMT. We know we need to have a 4-hour rating. You can fill in that parameter and it'll narrow your search just with those parameters. It gives me now 15 results. So not that 15 is an easy one to go through, but it's better than 7,500. So here I can look through these. And again, these are all links. I'm just going to grab the first one right there, that EGS Nelson Firestop. Again, we can see what we have here. In this case here, it's going to allow me to have multiple penetrants going through the hole. And when I look at everything that it goes down through here, it tells me a max 5 pipes. It tells me what I use to fill that cavity. And it tells me how I fill that cavity. And notice we got a ratio mix here. You have to do it per that ratio. Think of concrete. If I need 5,000 PSI concrete and it comes out and it's a little thicker than I want, so I add 20 gallons to the truck of water to thin it out, you think I got 5,000 pounds of concrete anymore, PSI? I weakened it. So the same thing here. It gives me a ratio. You need to mix it to get that ratio. You don't want it too dry because it'll crack and flake out. You don't want it too wet because then it won't have its rigidity that you need it to have. So when you have a system like this, arbitrarily ask the contractor, hey, what was your mix ratio? If they look at you with the deer in the headlights look because they just grabbed a bucket and put the mortar in, and they grabbed a bucket with water and poured it until they got a consistency they liked, That's not the right consistency. That's not a good fire stop. They probably get to break it out and try it a second time. A good friend of mine, Bill McGovern, used to be the chief electrical for Plano. He tells me, he says, you know, the first time was just for practice. Now let's do it right the second time. And then a good friend of mine, Dave from Virginia, he tells the story of, you remember how you put it in? Reverse that process. So with that, we're just a few minutes over. We had a couple of conversations that were good. Here's my contact information, my cell phone, my email. Now, Jeff Simpson is your first point of contact. He's my person that covers your area. But if he's not available, or you just really feel you want to reach out to me, feel free. I'll do the best I can to help you. But realize I got my area that I cover too. So I don't mind helping out where I can. And Robert will tell you, him and I have been contacting back and forth for multiple years now. So I make myself available,
yes.
even though Robert's not in my area. But Jeff is your key guy, Jeff Simpson. So with that, if you got any more questions, I'll do my best to answer them for you.
You talked about fire stops and fire blocks. Can you clarify?
So a fire stop is usually a tested system. A fire block is a prescriptive out of the building code. And the building code will describe exactly what a fire block is in prescriptive terms. And if Brian's still on here, Brian is just as competent at this stuff as I am. So Brian, if you have anything to say or want to comment, I welcome your comments as well. But that's my understanding is a fire stop is a tested listed system, and a fire block is prescriptive out of the building code.
Yeah, I would agree with that 100%, Jeff. So if you think about the transmission of air, smoke, fire through a building, there's like 4 levels of consideration. You have your energy considerations, which clearly is the least of concern, but still important. Above that would be draft stopping. Above that would be fire blocking. And then the highest level would be, of course, fire stopping. And each of the below sections, the air barrier and thermal barrier sealing will be prescriptive, mandatory requirements of your energy code. Draft stopping typically only is required for excessively large attic spaces. Fire blocking, as Jeff indicated, it's concealed combustible construction. So things like top plates, floor plates between floors, cornices, interior to exterior penetrations, you get the idea. And then of course, he went over all the fire stopping stuff. But clearly, as Jeff alluded to, possibly the most neglected component of an electrical premises wiring system is the fire penetrations. And it's something that we really need to be paying more attention to. Thank you.
Thank you, Brian.
This Marty Walsh, I have a question. If Jeff could go back to his last screen that was shown with the pipe conduit penetrations.
That one, Marty?
Yes. Can PVC penetrations be used, or is it always metallic?
No, some can. Let me go with one slide back, because see, now we have these numbers. See what number 2 is right here. So number 2 identifies what those penetrants are. We can see we got something boxed out. Here's where the slab stops, and we got something boxed out. So we have up to 5. We go to the information down below, and we look at what the penetrants can be. We can have a max of 5 in that opening. It tells me if there has to be any separation between them. But right here is telling me what those penetrants can be. So in this case, it can be a steel pipe, schedule 5 or heavier. It can be a conduit, nominal 4-inch or smaller steel metal tubing, or rigid steel conduit. So in this case, it cannot be a PVC, but there are systems that would allow PVC. It can be a copper tubing if we're using plumbing applications of a type L or heavier copper tubing, or it can be a copper pipe. So these are the only items that can be one of those 5 or all of those 5 with this separation. So in this case, if they were giving you, go back to the picture here, if they were giving you this CAJ 1040 as their detail, and you had PVC going through there, no, this is the wrong system. So in this case, Marty, PVC couldn't be used, but there are floor systems that are designed to allow PVC. It's just not this system.
Thank you.
You're welcome. Glad to hear you're out there, Marty. I hadn't talked to you in a while. Well, David, it's your show unless there's any more questions.
Awesome presentation. Thank you, Jeff.
Thanks, Dave.
Thank you, Jeff.
Okay, let me just mention our next two meetings.